Hello everyone, this is Shankho Shubhra Rai Kormokar and welcome to my channel that is Reverberation Guidelines. So আজকে আমরা ক্লাস 10 এর periodic table, periodic properties and the variation of periodic properties নিয়ে ডিসকাস করব। ক্লাস 9 এ আমরা periodic table সম্পর্কে বেসিক কিছু ডেটা জানতাম and আজকে আমরা বেসিক্যালি periodic table property, variation and the periodicity নিয়ে ডিসকাস করব। So here we start. So the first thing we need to know that is the concept of an element. An element is nothing but the pure substance and it is made by single type of atoms. Basically, an element is the species of atom having the same number of protons, that is, the atomic number must be same. Since 2016, there are 118 confirmed elements starting from hydrogen and 118 is going to be termed as an octanium. Elements 113, 115, 117 and 118 are the most recent discoveries and they have been confirmed by the I.C.S.E. Do remember that the atomic number or the number of protons of a certain element is the most important and signified data to express the concept of an element. That's why whenever we are going to express an element, we usually prefer the atomic numbers. That is the logic whenever we are writing elements 113, 115 or 1117. That means that elements are going to have 113, 115 or 117 number of protons inside it. We have told that there are 118 elements till 2016 and as a result to memorize the elements or to synchronize them into a regular order we usually prefer the concepts of periodic table. But the modern periodic table which we usually follow right now has not been delivered or has not been prepared at a glance. It has been developed through several ways. The first theory on periodic nature was delivered by the scientist Dobrynyas and his law is known as the Dobrynyas Law of Triad. Now we are trying to highlight on the Dobrynyas Law of Triad. This law is stating that the atomic mass of the middle element of a triad or three elements whole is the arithmetic mean of the atomic mass of other two elements if they have been arranged in their ascending order. Basically, if we look the lithium, sodium and potassium and we know the atomic masses of lithium is 7 and the atomic mass of potassium is 39. So if we try to measure the arithmetic mean of lithium and potassium, we will find that this will be 23 and the 23 is the atomic weight of sodium. But unfortunately, only 3 triads could be identified on that moment. So this was not a proper rule to measure the periodic property of every elements. The next rule to synchronize the periodic table was coined by scientist Newlands and the rule which has been generated from him is known as the Newlands octave rule. On his time period, he was able to give 62 elements which are known at that time and he has arranged them with the help of increment of atomic weight. He proposed that the physical and the chemical properties of the elements are going to be repeated after 7th element if the elements are going to be arranged with the increment of atomic weight. That is the logic. After 7th element, the 8th one is going to display the same physical and chemical property with the first element and that's why this is known as the Newlands octave rule. The next law on periodic table was proposed by scientist Mendeleev, and the logic to synchronize the periodic table is known as the Mendeleev's periodic table. Mendeleev also arranged the elements on the basis of relative atomic mass or the atomic weights. But he did something more. That's why his periodic table makes a huge differences. Mendeleev proposed that the physical and the chemical properties of the elements are the periodic function of the atomic masses. But those physical and chemical property are going to be organized in a periodic way, and they are going to be arranged in some horizontal rows arrangement, those are known as periods, and some vertical column of arrangements, those are known as groups. So Mendeleev was the first person to propose the concepts of periods and groups, and Mendeleev was able to arrange total 63 elements which were discovered till his time. Now we will discuss on the concepts of modern periodic table. So the modern periodic table is the long form of periodic table, and this is based on the property of atomic numbers. So we have told earlier that an element is going to be represented with the help of the basic identification mark, that is the atomic number or the proton number. So modern periodic table is based on that basic unique identification mark. The modern periodic table is stating that the physical and the chemical property of an element is the periodic function of the atomic number, that is the proton number. And the modern periodic table is the tabular arrangement, and it has the vertical columns which are known as groups and the horizontal rows which are known as periods. And this is the regular trend to describe the physical and chemical property of those elements. The modern periodic table looks like this, where we have not implemented the artificial elements. As a result, we have eliminated the atomic numbers of 113, 114, 115 and 117. If we observe the modern periodic table very carefully, then we will observe that there are 18 vertical columns, and those 18 vertical columns are going to be termed as groups. So in a modern periodic table there are 18 groups. Now we are implementing the artificial elements also. As a result, the modern periodic table looks like this, where the 18 groups are going to be termed by different names. The group 1 is going to be termed as the alkali metals. Group 2 is going to be termed by alkaline earth metals. The group 3 to 12 is going to be termed as transitional metals. Group 13 is going to be termed as boron family, as the first element of that group is boron. Group 14 is known as the semiconductor groups. Group 15 is known as the nitrogen family, as the first element of that group is nitrogen. Group 16 is known as the oxygen family, as the first element of that group is oxygen, and group 16 is also known as chalcogen. Next, the group 17, that is known as halogen. Group 18 is known as the noble gas or the inert gas. Remember, hydrogen is the evil element. It can be placed in group 1 as well as group 17. That's why we have not termed the hydrogen as the alkali metal, and the transitional metals show the variable valency as they have the vacant d orbitals. In the other hand, in the modern periodic table, there are total 7 horizontal rows, and those 7 horizontal rows are known as periods. Now, these periods are going to be termed by period 1, shortest period, or very short period, which contains only 2 elements. Period 2 is known as the first short period, contains only 8 elements. Period 3, the second short period, contains only 8 elements. Period 4, it is the first long period, contains 18 elements. Period 5, this is going to be termed as second long period, contains 18 elements. Period 6, this is the longest period, contains 32 elements. Period 7, this is known as the incomplete longest period. It may contain 32 elements. Now, observe the modern periodic table very carefully. We will find that there are two more rows placed at the bottom of the periodic table, and these two rows are termed as lanthanides and actinides respectively. Basically, these two rows belongs on the period 6 and period 7, but it has a very special property. The subperiod of period 6 is known as the lanthanides. Lanthanides is the series of elements contains 15 elements of atomic numbers 57 to 71, and they are going to be started from lanthanum through lutetium. The next row belongs to the subperiod of period 7, and this is known as the actinides. This series also contains 15 elements of atomic numbers 89 to 103, and the starting element is known as the actinium and up to lawrencium. Remember, these two groups are nothing but the rare of rarest elements. Now we will highlight on the periodic nature, that is the periodicity of modern periodic table. So, in the context of chemistry and the periodic table, the periodicity refers to the trend or the recurring variation of the regular interval of elements' properties with the increment of the atomic numbers. So, periodicity is nothing but the function of same type of physical and chemical nature with the regular interval or a certain interval of the elements if they are going to be arranged with the increment of atomic number. Now we are trying to realize the periodicity or the periodic nature with the help of group 17, that is the halogen group. The halogens are highly reactive elements. As a result, the halogens can react with any other elements to form the compounds. They tend to gain electron. As a result, they are highly oxidizing agent. The reactivity of the halogen increases on ascending the group. That means if we move upward through the group, then we will find that fluorine is the most reactive as it is placed at the top of group 17. They form anions. That means all the halogens accept an electron and becomes anion. The melting point increases regularly if we move down the group. That means the metallic character is going to be increased. Number 6. All the halogens are nonmetals in nature. Number 7. They are high electronegative elements. Now we are trying to realize the periodicity or the periodic properties of the alkali metals or the group 1 elements. So alkali metals have 1 electrons in the outermost shell. If we observe all the alkali metals of group 1, then we will find that they all have only 1 outermost electron. Number 2, they tend to lose the outermost shell electron and becomes converted into a cation of charge plus 1, that is monovalent ions. Number 3, such type of properties make them most electropositive elements. Number 4, they are not found in pure state as they are highly reactive in nature. Number 5, ionic and atomic radius are going to be increased regularly down the column. Number 6, alkali metals has the largest radii than other elements in the corresponding period. So if we move across a period, then all the alkali metals will contain the largest radii. Now we will discuss each and every periodic property. That is, each and every periodicity will be discussed right now. The first item which is going to be discussed is known as the electronic configuration. The electronic configuration is nothing but the numerical representation of the arrangement of electrons distributed in the orbits of an atom. Now, if we try to realize the electronic configuration across a period, then the maximum electrons that can be contained by a energy level is known as 2 into n squared, where n is the energy level. Now, if we move for the first cell, then k will be 1. As a result, n will be 1. So, this will be 2. As a result, the first period contains only 2 elements. For the second one, n will be 2. That is, this is L cell. So, here the total number of elements can be accommodated as 2 into 2 squared, that is 8. So in the second cell there are maximum 8 elements can be present. In the same way, in the third cell there are 18 elements are going to be observed. Now if we move down a group, then we will observe a very interesting thing. The elements in the same group have the same number of electrons in the outermost shell, leading to the same valency of the electronic configuration. As a result, if we observe the electronic configurations of lithium, sodium and potassium, then we will observe that lithium has 2 electrons in K and 1 in L, but sodium has 2 electrons in K, 8 electrons in L and 1 electrons in M, and potassium have 2 electrons in K, 8 electrons in L, 8 electrons in M and 1 electron in N. So this is very much similar down a group. Now remember, lithium, sodium and potassium, all three elements are present in group 1. As a result, in the group 1 or the alkali metals, all the elements are containing 1 electrons in the outermost shell. As a result, we can easily state that this is the periodic nature or the periodicity of electronic configuration down the group. The next periodic property which is going to be discussed is known as the atomic size. The atomic size is nothing but a function of atomic radius. That means if the atomic radius is increased, then the size will be increased, and if the atomic radius is going to be decreased, then the size will be also decreased. So basically, the distance between the center of the atom and the outermost shell is the measurement of atomic radius. The atomic radius has two depending factors. One, the number of cell, and number two, the nuclear charge. Now we are trying to discuss the factors, that is the number of cells. If we try to follow any of the groups, then we are thinking for the group 1, that is alkali metals. We know lithium, sodium and potassium all are placed in group 1, but lithium has only 2 cells, but sodium has 3 cells and potassium have 4 cells. As a result, we can easily state that potassium is the biggest in size and lithium is the smallest in size. Because the number of cells is going to be increased, the size of the atoms will be increased. In the other hand, if we try to discuss the concept of nuclear charge, then we will find that the more the nuclear charge causes the decrement of the atomic size, because the electrons are going to be attracted towards the nucleus more immensely if the nuclear charge density are going to be increased. Clear? Now we are trying to discuss the periodicity of atomic size across a period. Across a period, the size of the atoms are going to be decreased, because within a period the electrons are going to be added up in the same cell, but in the same time there is another proton which is going to be attached in the nucleus. As a result, the nucleus are going to be more dense with respect to the positive charge, but as there is no increment in outermost cells, the outermost electrons are going to be attracted more immensely. As a result, the total size will be reduced. That's why the atomic size across a period will be reduced. Now we are trying to follow the atomic size trend down a group. Then we will find that the size of the atoms are going to be increased if we move down the group. This occurs only because the successive addition of cells. If we try to realize hydrogen, lithium, sodium and potassium, then all of them are placed in group 1. Then hydrogen has only one cell, lithium has 2 cells, sodium has 3 cells and potassium has 4 cells. So we can state obviously that hydrogen has the smallest size in nature, lithium is moderated, sodium is greater than lithium but smaller than potassium, and potassium has the biggest size. So we can state clearly that the atomic size reduces if we move from left to right across a period, and the atomic size will be increased if we move top to bottom down a group. Now we are trying to clarify that the cations are smaller than the parent atoms. Cations are going to be prepared if an atom releases 1, 2 or 3 electrons. As a result, the remaining electrons are genuinely less than the number of protons placed inside the nucleus. As a result, the immense attraction of the protons on the electrons reduces the size of the cations with respect to its parent atom. Similarly, we can answer that anions are larger than the parent atom. We know anions are going to be formed by the gaining of electrons, 1, 2 or 3 electrons. Thus, the number of electrons becomes more than the protons placed inside the nucleus. So, the effective charge in the nucleus is less with respect to the electrons present in the outermost orbits. So, the less inward pull is experienced, hence, the size expands. The next periodic property, which is now going to be discussed, is known as the valency. The valency is nothing but the combining capacity of an atom. Basically, to achieve the stablest electronic configuration of the nearest inert gas, the number of electrons gained, shared, or released by an atom is known as valency. To realize valency, first realize the valence electrons. So in physics and in chemistry, the valence electrons is the outermost shell electrons present in an atom that can participate in the formation of chemical bond if the outermost shell is not closed. Basically, the elements always try to have 8 electrons in the outermost orbit, exception hydrogen, helium, lithium, beryllium, and boron. They always try to have the stablest electronic configuration of the nearest inert gas, that is helium. That is, they always try to have 2 electrons in the outermost orbit. But the rest elements always try to have 8 electrons in the outermost orbit. As a result, they either gain or releases the outermost electrons or sometimes share the outermost electrons to have such stablemost electronic configuration. Now, the valency is a very interesting property. So, across a period, the valency initially increases and then decreases. If we try to observe the chart, then we will find at group 1, lithium will show 1 valency because it will release its outermost electron. In group 2, beryllium will also exhibit the valency of 2 because it will release 2 electrons. In group 13, the boron will also show 3 valency, which means it will release 3 electrons. In group 14, carbon will also exhibit 4 valency. They will go for the sharing. In group 15, nitrogen has 5 valence shell electrons. As a result, they will accept 3 electrons, and as a result, valency will be 3. So the first time it is going to be decreased. And in the same way, in group 16, oxygen has 6 outermost electrons. As a result, it will accept 2 electrons and the valency will be 2. Fluorine, it has 7 outermost electron, it will accept 1 electron, and neon, it has 8 electrons in the outermost orbit, so it will neither gain nor lose the electrons, so the valency will be 0. But unfortunately, we don't have the scope to discuss about the valencies of group 3 to group 12, that is the transitional elements, because they show the variable valency due to the presence of their incomplete d orbital. Now, down a group, there will be no change in valencies because we have stated earlier that the electronic configuration down a group will be ditto same. As a result, down a group, all the elements will have same number of outermost electron. If we try to follow the valence electrons, then we will find that in the outermost orbit of group 1 there are only 1 electrons, group 2 there are 2 electrons, group 13 there are 3 electrons, group 14 there are 4 electrons, group 15 there are 5 electrons, group 16 there are 6 electrons, and group 17 there are 7 electrons. As a result, the group 1 and group 17 both will exhibit the valency of 1. Group 2 and group 16 both will exhibit the valency of 2. Group 13 and group 15 will exhibit the valency of 3, and group 14 will exhibit the valency of 4. But there is a basic difference between the valencies of group 1 and group 17. The group 1 elements release the outermost electron, that's why their valency is going to be termed by +1, but for the group 17 they accepts 1 electron and their valency is -1. Equally, for group 2 and group 16, both have the valency of 2, but group 16 accepts 2 electrons, that's why their valency is -2, but group 2 releases 2 electrons, that's why their valency is +2. Similarly, group 13 and group 15 both have the valencies of 3, but group 13 releases 3 electrons, but group 15 accepts 3 electrons. And group 14 has a valency of 4 because they go for the covalent bonds. The next periodic property which is going to be discussed is the metallic character. So metallic character refers to the level of reactivity of a metal. Metal tends to lose the electrons in the chemical reactions. Now we will discuss on the periodicity of the metallic character. So there are two depending factors of metallic characters. Number one, the atomic size, and number two, the nuclear charge. Number one, the atomic size is going to be discussed right now. If the size is going to be increased, that means the outermost orbit remains at a huge distance from the nucleus. As a result, the less nuclear pull is going to be exerted on it. So the outermost electrons can be removed very easily. So the metallic character will be increased. That's why we can state if the size of the atoms are going to be increased, then the metallic character will be increased. In the other hand, the greater the nuclear charge density, the greater force exerted by the nucleus on the outermost electrons. As a result, it's difficult to remove the electrons by the atoms if the nuclear charge density becomes maximum. Now, across a period, if we try to realize the metallic character, then we will find that the metallic character decreases as we start moving from left to right across a period, because we know from left to right across a period the size of the atoms are going to be decreased. As a result, the nuclear charge density will be immensely increased. So it's difficult for the elements to release the outermost electrons. That's why the metallic character are going to be reduced. Now, down the group, the metallic character is going to be increased because we know down the group the size of the atoms are going to be increased, because we know down the group an extra cell is going to be added up every time. So it's easy for the elements to release the outermost orbit electrons. So the metallic character is going to be increased down the group. Now, to follow the periodic trend of the metallic character, we are concentrating on the basic figure. So, if we follow this diagram, then we will easily have that the metallic character is going to be decreased across a period if we move from left to right, because the size of the atoms are going to be reduced. As a result, metallic character will be reduced as the charge density is going to be increased. In the other hand, down the group, the metallic character increases because the size of the atoms are going to be increased. As a result, the tendency of losing electron increases rapidly. Now we are going to discuss the periodic property which is known as the non-metallic character. Basically, this is just the opposite tendency of metallic character, and in non-metallic character this relates to the tendency to accept electrons during the chemical reaction. Basically, the elements which have 5, 6 or 7 electrons in the outermost cells, they try to accept 3, 2 or 1 electrons to fulfill their outermost orbit electrons as octave, and such type of property is known as the non-metallic characters. Now, if we try to describe the periodicity of the non-metallic character, then we will find two depending factors. Number one, the atomic size, and number two, the nuclear charge. We are now trying to describe the atomic size. The smaller the atomic size, the greater is the nuclear pull, and as a result, the tendency to gain electrons also increases. As a result, the non-metallic character also increases. In the other hand, the greater the nuclear charge, the greater the tendency to gain electrons. Hence, if the size of the atoms are going to be reduced, that also becomes the same logic to increment the nuclear charge density, and it also increases the non-metallic character. Now, if we move across a period from left to right, then the non-metallic tendency will be increased. As we know that across a period from left to right, the size of the atoms are going to be reduced. As a result, the tendency of attracting electrons is going to be increased. So, non-metallic character will be increased. Now, if we move down the group, then we will find that due to the addition of new cell over the successive period, the atomic size is going to be increased. As a result, the effective attractive force on the outermost electrons is going to be reduced. As a result, the non-metallic nature is going to be reduced and the metallic character is going to be increased. We have told earlier that the non-metallic character is just the opposite character of metallic one. If we try to follow this trend, then we will find that from left to right across a period, the non-metallic character is going to be increased, whereas the metallic character is going to be increased from right to left across a period. In the same way, if we move down a group, the metallic character will be increased, but surprisingly, the non-metallic character will be reduced. The next periodic property which is going to be discussed right now, that is the ionization potential. So ionization potential is also known as ionization energy or the ionization enthalpy. Basically, ionization potential or the ionization energy is the amount of energy or work done required to remove the most loosely bound electron of the outermost shell, that is the valence electron of an isolated neutral gaseous atom. Now, if we try to define the periodicity of the ionization potential, we will again find two basic factors. Number one, that is the atomic size, and number two, that is the nuclear charge. If we try to highlight on atomic size, then we will find that the greater of the atomic size, the lesser the force of attraction on the outermost electron. As a result, it will be easier for us to remove the external electron. So, if the size is going to be increased, then the ionization potential will be reduced. But for the nuclear charge, the greater the nuclear charge, the greater the attraction for the electrons. As a result, if we try to remove the outermost electron which has a greater nuclear charge, then we need to apply huge amount of work or energy. So for the higher nuclear charge elements, we need to follow the more ionization potential. Now, across a period, if we move from left to right, then we will find that the ionization energy or the ionization potential is going to be increased. As we know, from left to right, the size of the atoms are going to be decreased. So, ionization energy will be increased, but group 2 and group 15 elements are going to show an exception. For a short note, you need to know that the group 2 and group 15 shows exception because for the group 2 they have the completely fulfilled s orbital, and for the group 15 they have the half filled p orbital. Though this is not our cup of tea, so we will not discuss anymore. Down the group, the ionization potential is going to be reduced obviously, because we know down the group the size of the atoms are going to be increased as one cell is going to be added up every time. As a result, the size is going to be increased, so less the nuclear force is going to be realized on the outermost electron. As a result, we can easily extract the outermost electron, so the IP will be reduced down the group. If we don't consider the exceptions of group 2 and group 15, then ionization potential or the ionization energy or the ionization enthalpy will be increased across a period. But the ionization energy will be reduced down a group because the size is going to be increased down a group. The next periodic property which is going to be described right now is the electronegativity. Electronegativity is the measurement of the tendency of an atom to attract a bonding pair electron towards itself. Basically, during a covalent bond, there is the sharing of electrons, and the tendency of attracting the shared pair electrons towards itself is known as the property of electronegativity. We use Pauling scale to measure such type of electronegativity. The fluorine has been assigned by 4.0 in electronegative scale, that is the most electronegative element we have ever discovered. And the values range down to cesium and francium, which has the least electronegativity of 0.7 rating. The electronegativity has also two factors, and the depending factors are the atomic size and the nuclear charge density. Now we are trying to discuss the atomic size. The greater the size of the atoms, the lesser the electronegativity, since the electrons being further away from the nucleus, and as a result they experience a less amount of force of attraction. In the other hand, if the greater the nuclear charge is going to be realized by the external electron, then those type of elements will act as more electronegative element, because due to the increment of nuclear charge density, they can attract the outermost electrons with a greater force. Now we are trying to realize the proper concept with the help of the carbon and chlorine bonding in 1,1,1,1 tetrachloromethane. We know chlorine is placed in group 17. As a result, the size of the chlorine is very small, and that's why the tendency of attracting electrons is greater. As a result, they attract the bond pair electrons towards themselves, and they are going to be slightly negative charged, that is del minus. In such way, 4 chlorines are going to be termed by light negatively charged, and the carbon is going to be charged by slightly positive one, and such type of configurations are shown in electronegativity. Now, if we move left to right across a period, then we will find that across a period, the size of the atoms are going to be reduced. As a result, the greater the nuclear charge density is observed. As a result, the value of electronegativity increases across a period in modern periodic table. But down a group, if we move downward, then the size of the atoms are going to be increased. As a result, the lesser the attractional force is going to be applied on the outermost electrons. As a result, the electronegativity is going to be reduced and the electropositivity is going to be increased. Now, with the help of this chart, we are trying to describe the periodicity of the electronegativity. Across a period, from left to right, the electronegativity is going to be increased as the size is going to be reduced. But down the group, the size of the atoms are going to be increased. As a result, the electronegativity will be reduced. The last periodic property which is going to be described right now is the electron affinity or electron gain enthalpy. Basically, this is the amount of energy released while converting a neutral gaseous isolated atom into a negatively charged gaseous anion by adding an electron from outward direction. This is known as the electron affinity. Now, while we are trying to describe the periodicity of the electron affinity, we get two key factors. Number one, the atomic size, and number two, the nuclear charge. The atomic size is going to be described right now. The smaller the atomic size, the greater the electron affinity, because the effective attractive force between the nucleus and the valence electrons is greater for the smaller atoms, so the electrons are held firmly. In the other hand, if we try to describe the nuclear charge, then we find the greater the nuclear charge, greater the electron affinity, because increment of the nuclear charge increases the effective attractive force between the valence electrons. Now, if we move across a period, then we will find that the electron affinity increases from left to right because the decrement of the atomic radius causes the immense attraction on the outermost electrons. As a result, the electron affinity increases. But down the group, if we move downward, then we will find the atomic radius is going to be increased, so the electron affinity will be reduced. The electron affinity shows some exception. We told across a period from left to right the electron affinity is going to be increased, but for the group 2 and group 15 these are the exceptions, and we know the logic behind them. We told earlier that the group 2 has the full filled s orbital, and for the group 15 they have the half filled p orbital. The inert gases have the electron negativity of 0, and group 2 and group 15 don't show the regular trend of electron affinity. But if we try to describe the electron affinity tendency in a regular manner, then across the period, if we move from left to right, then the electron affinity will be increased, and down the group, if we move from top to bottom, then the electron affinity will be reduced. Where we have not considered the exceptions of group 2 and group 15. So, end of the day, stay home, stay safe,